Good morning, Honors Algebra. Today we are going to look at steps to solve a multi-step equation. Our clear learning target is I can solve a multi-step equation with variables all on one side, and we'll get to some notes where there are variables and constants on both sides. So some notes that we want to take. First, we would like to distribute if necessary. Number two, we want to combine like terms. That means that we are going to combine terms, constants together on the same side of the variable and terms with a variable on the same side of the equation. And then we will solve for the variable by isolating the variable. Okay, so in our first example, I'm going to jump down here to, let's start with number 3. We'll put the answer keys on ManageBack for all the problems, but we're only going to work through some of the problems. So in number 3, I have 4 times m minus 5 times the sum of 3m and 10 is equal to 126. Okay, a couple things I like to do when I'm solving equations is put a line down the middle or a line separating each side. Think of it as a balance. Then I'll notice here at this minus 5, I'm going to change that to adding a negative 5. Now the negative 5 is by the parentheses, so we know that we have to multiply. We're going to distribute that negative 5 to the 3 times m into the positive 10. So let's go. 4 times m plus negative 5 times 3m. I'm putting negative 15 in parentheses, plus negative 5 times 10 is negative 50. On the other side of my equal sign, I still have that 126. Okay, I've distributed. Now I want to combine like terms. I can combine 4m and negative 15 because they both have the variable m to the same power. I do not want to combine those with negative 50 because that's a constant. So 4 plus negative 15m will leave me with negative 11m plus a negative 50, or I can just say minus 50 equals 126. Now I'm ready to use additive inverse. I notice that the term on the negative 50 on the left is a constant, so is the 126. So I want to get those constants all to one side and the variable keep the variable on the opposite side. So then I have negative 11 times m, and that zeroes out, is equal to 176. Now I'm ready for multiplicative inverse. So because negative 11 times m is multiplication, the inverse of that is division. So I'm dividing both sides by negative 11. So negative 11 times m divided by negative 11 yields positive 1m. 176 divided by negative 11 is negative 16. So there we go for that first example. Next example, I really like number 4 because it has 2 circumstances or 2 places where we apply the distributive property. So we see that we have negative 3 times k, and negative 3 times 8. But is that a positive 8 or a negative 8? Well, be careful. It's a negative 8. So I'm changing that minus to plus a negative. Over here, before I distribute this first part, I'm going to mind this subtraction sign right here. And there is a 1. If I don't see a number, I know that it's 1. So I'm adding a negative 1. And that negative 1 is going to be multiplied by 1k and negative 1 times positive 5. I've got a positive there, so I don't have to worry about that. I like to go ahead and draw this line for my equations. Then negative 3 times k plus negative 3 times negative 8 is going to be a positive 24. I'm going to put this plus sign right there. I've got negative 1 times k. I'm going to put that in parentheses, a negative 1k. I'm just going to put it negative k. I could have put this in parentheses too, keeping all my terms in parentheses. And then I have a positive negative 1 times 5, and that is negative 5 is equal to 23. So I notice on the right side, I have the term 23. It's a constant. On the left side, I've got like terms of negative 3k and negative k. I can use the commutative property with 24 and negative k, and that becomes, then I would combine the negative 3k and the negative k into a negative 4k. Notice that positive 24 and negative 5 are like terms. When I combine those, that will provide me with the answer of, or the simplification of 19 equals 23. Now that I've distributed, now that I've collected my like terms, I'm ready to use that additive inverse. So additive inverse, I don't want to do an additive inverse with a negative 4k by adding 4k to both sides. I could do that, but I've got a constant of 19 on the left and a constant of 23 on the right. So get those constants to one side, subtract 19, subtract 19. On the left side, I have negative 4 times k. This zeroes out. Don't have to worry about that. I've got 23 minus 19. 23 minus 19 is conveniently 4. All right, ready for multiplicative inverse. I've got to reverse that division, reverse multiplication with division. Negative 4 times k, I want to divide by negative 4 so that I get k all by itself. So I'm dividing both sides by negative 4. This is going to be 1k, so 1 times k is equal to 4 divided by negative 4 yields a negative 1. I could always substitute this number, whatever the value of the variable is. I could substitute it back here in my original equation, and both sides should balance out and equal 23. Moving along, we'll look at number 9. Number 9 and 10 on this page. Zoom out just a bit. Like number 9 because we've got distribution of a negative fraction. So that looks really exciting. So let's look here. Let's read the problem. 7 minus 5 halves times the difference of 8 times r and 6 plus 2r equals 32. Let's go ahead and put that balance. Got to balance both sides of my equation. So first I need to distribute, but because that's a negative, I'm going to make that into adding a negative. Then I'm ready to distribute that negative 5 halves. So, of course, it distributes to both of these numbers. Be careful. I'm going to have the difference of or subtraction here, so I may want to do plus a negative 6. That'll help me when I start multiplying. So we have 7 plus negative 5 halves times 8 times r divided by 1. Guess I should have said that. When I have a fraction and whole numbers and I'm distributing, it's always nice to put You put it in fraction form, and any number divided by 1 is itself. So I can take care of that by putting it over 1 or divided by 1. Then I'm putting the plus sign. I'm going to go back. I've still got that -5/2 that I need to distribute to that -6 divided by 1. Got to get that 2r in there, equals 32. So let's start tidying this up. 7 plus. Now, different ways to do this. Your parents or a sibling might show you a different way than what I'm showing you. It's all good and all fine as long as we get the same answer. I'm just going to go ahead and multiply straight across and then simplify by dividing by my denominator. -5 times 8r makes that term -40 times r divided by 2 plus. Now, this next term, I've got a -5 times -6. That becomes 30 divided by 2 plus a 2r equals 32. Okay, let's keep simplifying. -40 divided by 2 is -20r plus 30 divided by 2, 15 plus 2r equals 32. Now I can start looking for my like terms. On the left side, I've got -20r and I've got 2r. If I combine those, if I use commutative property, associative property, those combine to be -18 times r. And then I've also got 7 and 15. So 7 and 15. 7 is positive, so that becomes +22 equals, I had a mistake here earlier, that's 32. Okay, so now I am ready to, I notice I've got a term with a variable. I've got a constant. On the other side, I also have a constant. So subtract 22 from both sides. And I'm going to come up here and finish my problem. I've got -18 times r equals, because that zeroes out, equals to 10. All right. Now, what's next? Additive, multiplicative inverse. Divide by -18. So, any number divided by itself will leave just a 1. 1 times r. 10 divided by -18. Okay? Simplifies to, I can divide both by 2, and that becomes 5 over -9. Because this is positive and that's negative, I could make that -5 over +9. And there's my answer. R equals -5/9. Nice fraction answer in there. All right, let's have some fun with a word problem. Number 10. Got 5 times the difference of twice a number and 3 decreased by the sum of the number and 8 equals 13. Wow, there's a lot going on in this problem. So 5 times the difference of, I don't know if you remember this, but difference of means that I'm going to use parentheses. So I see where I'm going to distribute 5 times the difference of twice a number. I'm just going to call it n. I could have called it x, but I'm going to call it n. Twice the difference of twice the number and 3. And then that's decreased by the sum of the number and 8. So it's decreased, and when I see sum of, I know that I've got to take that number, that 1n and 8. I'm adding because it says sum of. This was difference of 2 twice a number and 3 is equal to 13. All right, 2 places where I'm going to distribute 5 to the 2n and 5 to that -3. If you want to make it plus a -3, that's 10n plus 5 times -3, -15. Be careful here. There's a 1 there. I've got to distribute not a +1, but a -1. Negative 1 times n and negative 1 times 8. So that becomes a negative 1n, or I could have written it as just negative n, plus negative 1 times 8 is a negative 8 equals 13. Okay, let's look for those like terms. 10n and negative 1n are like terms. Combine those into 9n. Then I've got negative 15 and negative 8 that I'm combining together. They combine to be negative 23. So that side is tidying up, and I've still got 13 on the right side. Ready for that additive inverse. Add 23 to both sides. And then I have 9 times n is equal to 36. This is nice because this is going to, the variables, the number is going to be a whole number. Since it's multiplication, I need to do the inverse, which is division. So 9 divided by 9 will leave me just with that 1n. And 36 divided by 9 will result in 4. So n equals 4. Okay, so those were solving equations, multi-step equations. What we want to do next is come down here and look at equations with variables and constants on both sides. So just to go over a few notes, again, distribute if necessary. Secondly, combine like terms on either side of the variable. Thirdly, we want to use additive inverse to move the variables to one side. Likewise, we want the constant, that number by itself with no variable, on the other side, on the opposite side of the equation. Then, fourthly, we're usually ready to solve. So let's look for a good one. Actually going to go ahead and just do number 2 first. And again, there are more ways than one to do these kind of problems. There are at least 4 or more ways to do variables on both sides. I find it kind of handy to put that line so that I know that both sides of my equation have to balance. Sometimes up here, I'll put x is equal to the number, because I know I want to get the variable to one side and the constant to the other. Remember, it could be the number is equal to the variable. Equal is equal, and it doesn't matter if you have the constant on the left or the constant on the right, as long as you have the variable and the constant on opposite sides. So, what can I do first here? Don't have to do any distribution. I cannot combine negative 6x and 14, nor can I combine 12 and negative 8 times x. So, I need to either add 6x to both sides or add 8x to both sides. Which should I do? Well, I kind of like to do it this way. Add 6x to both sides. Now, 6x, negative 6x, and positive 6x zero out. So then I'm left with that 14. Bringing that down here, got the other side of my equals. I've got 12. Now, be careful here. I've got a negative 8x plus a 6x. So that's going to be a negative 2 times x. Constant on the left. On the right, I've got a constant and a term with a variable. Remember that 2 is called a coefficient. So, do I need to move the 14 over here? Well, I could, but I'll go round and round. There's a simpler way to solve. Since this is a 12, I want to subtract 12 from both sides because this way I'm getting rid of the constant on the right side. On my left, I've got 14 minus 12, 2. This becomes 0. I could write it or not. And then I bring down this negative 2x. So really I have 2 equals negative 2 times x. Now I'm ready to do that multiplicative inverse, dividing by the coefficient of the variable, which is negative 2. So simplification shows me that my variable 1x or x is equal to negative 1. Most of the ones on that page are pretty simple like that. Just remember, watch your subtraction signs. Remember, it's adding a negative. I thought it would be great to go over problem like 10. Or 11. I'm going to choose number 11 because we've got 2 sides of an equation. We've got distribution on both sides. Probably going to run out of room. It's okay. So let's go through here. 5 times x minus the difference of x and 18 is equal to 6 minus 2 times the sum of x and 15. Let's go ahead and make some notes. There's a 1 right there. That subtraction means that I'm adding a negative 1, which I'm going to have to distribute to the x and the 18, or the negative 18 on the other side of the equation, plus a negative 2 times the x, and that negative 2 times positive 15. Right, continuing on, 5x plus negative 1 times x. I'll just write it as a negative x. Some people like that 1 there. Then I have plus negative 1 times negative 18. That's not too bad. That's positive 18. Didn't need that parentheses there, but it doesn't matter. Right side, I've got 6 plus 2 times a positive x, negative 2 times positive x, plus negative 2 times positive 15, negative 30. Okay, there's too many colors. On the left side, before I just start moving constants to one side and variables to the other, I notice I can combine some like terms. 5x and negative 1x, they become 4x plus 18. Oh, goodness gracious. Seem to be back in business. Plus 18, it's not a negative, I don't need the parentheses. On the right side, I look at my terms. I've got 6, negative 2x, and negative 30. I can't combine the variable with either one of those terms because it's a variable. But I could take the 6 and the negative 30 and combine those. So I still have negative 2 times x. And when I combine 6 with negative 30, I have negative 24. It's getting good. Okay. So now you can see we've got on the left side, term with a variable, term with a constant. Likewise on the right side. So what do I want to do first? Should I subtract 4x from both sides? I sure could do that. If I subtract 4x here, I can only subtract it or if I subtract 4x, I have to subtract it from negative 2x. Let's just do something a little different this time. Let's say add 2x to both sides. Add 2x, because this is going to zero out negative 2x plus 2x becomes 0. What I do to one side, I do to the other. So 4x plus 2x become 6x plus 18 equals, this is 0, I can write 0 or I can leave it out, plus negative 24. Let's just erase that. 0. Negative 24. Okay. Because on the left side, I have the positive 18, I can do additive inverse. Additive inverse. So instead of adding, I'm subtracting 18 from both sides. So left side, bring down the 6x. This becomes 0. Right side, I have negative 24 and I have negative 18. When I combine two negatives like that, I'm just adding the two negatives, that's negative 42. Now I want to undo my multiplication with division. So I will divide both sides by the coefficient of x. X is equal to negative 7. Voila, we have our answer. We could always check that negative 7 by substituting it in here for the 5, or for the x, sorry, for the x here, and then the x there. So those are the only problems I'm going to do on these right now. I would like for all of you guys to do as many of these problems as you can and check the key. Obviously, the ones on this page are super important because you're practicing variables on both sides of the equation where you have to distribute, sometimes a negative, where you're not expecting it. So make sure you go ahead and practice all of this and check your answers with the key on ManageBack. Have a great day.